we're continuing with section 5.2, and now we're discussing a few properties of definite integral. The first property is integral from a to b of f of x d of x. See the bounds, the limits starts from a. A is the lower bound, b upper bound, is equal to negative integral from b to a. Again, you have to know this when we talk about upper and lower, that means that we're changing the order of the. So that's the negative of the other integral when we change the order of the bounds. So what does this mean? First integral, the base of each rectangle in the Riemann sum has length b minus a divided by n, while in the second integral, each rectangle has a base of a minus b divided by n. And so and this is how it's explained, because in the Riemann sum, you have delta x of one thing is the negative of the delta x of the other thing, and so that's how we measure this, basically. Now, property number 2, integral from a to a of f of x dx is equal to 0. And that makes sense, because what kind of a rectangle can we create on interval a and a? A rectangle with the width that is equal to 0. I click at question 2. Suppose a is not equal to b. Integral from a to b of f of x d of x is equal to 0. Must be true. Must it be true that f of x is equal to 0 for all x in a and b? So give yourself a minute. Again, coming back, a is not equal to b, and we're calculating integral from a to b of f of x dx. Can it be 0 without f of x being 0 everywhere? And the answer is yes. I mean, the answer to this question is no, because there's a possibility that the integral, here's the example. If you look at this, the blue, the cyan, this is the line y equal to x, and so the function is f of x equal to x. Function is f of x equal to x. And if you look at the cyan part, that's above the x-axis, is 9/2. The pink part is negative 9/2, and they cancel each other out. So the answer is no, because this example exists, this counter example exists. Now, integral property 3, integral from a to b, c dx is equal to c times b minus a. What does this mean? Look at the integrand. What is the integrand? Integrand is this part, right there. That's the f of x part. F of x equal to constant c, that's the basic. And so any, if I'm computing the area between a and b in here, then I will have that rectangle. And what is the area of that rectangle? And it's going to be the y value for the function, which is c, times a b minus a. So for constant function, that's what you get. Now, the next one is very interesting. If you have integral from a to b of f of x dx, then it can break down into two integrals. For any c, and I show you when c is between a and b how it works, and then similarly it will be implied when c is not between a and b. but this integral can be broken down to two integrals of f of x dx, one from a to c, the other one from c to b. And so here's the picture. Let's imagine this is integral from a to b of f of x dx, right? The area underneath this is that integral. Now let's find a point C between a and b and try to basically break down the two the area into two pieces. And then look at this. One of them here, the pink one right here, is this integral, and this one is that integral. See, a to c, c to b. So it broke down into two pieces basically. And so this is what's going to happen. So what if C is not between A and B? And so let's say C is not in A and B, and C is it's A, then B, then C. So in this case, I can break down integral A to C of f of x dx. Don't forget that dx. dx tells you what the integral, what's the variable for the integral. A to b of f of x dx plus b to c of f of x dx. And in here, I'm going to basically subtract this integral from both sides and get integral a to c of f of x dx minus b to c of f of x dx, integral a to b of f of x dx. Oh, there was another property, wasn't there? The other property, so let's rewrite it. If I switch the two bounds, the sign changes. And so I end up with this. So in this case, I tried when c is not inside the integral a and b, I still got the same value that I got over there. So now, property number 5. If I take the integral from a to b of f of x plus gx dx, this is a summation function, sum of the two functions, then it would be integral from a to b of f of x dx plus integral a to b of g of x dx. And so this comes from basically the fact that every time you're building up an f of x plus gx function, then the height of each, let's say both of them are going from the same, both f of x and g of x are being integrated over the same interval, and then the summation of them is integrated over the same interval as well. And therefore, every rectangle in the summation has the height of the two corresponding rectangles in either of the functions. Here, the c of x, this rectangle, the height is the same as b, height of b and a added together, basically. And property number 1, when the order of the limit bounds change, the sign changes, basically. Now, oh no, that one was just, that one is just, now, and there's another property that is a direct consequence of property number 5, and that's integral from a to b of f of x minus g of x dx is equal to integral from a to b of f of x dx minus integral from a to b of g of x dx. property number 6. A constant multiplied by the function, the constant actually comes out of the integral, basically. It's going to be, if you have c times a function, the constant comes out of the integral, becomes c times integral of a to b of f of x dx. All these properties should remind you of similar properties that we had for derivatives, and except instead of derivatives you see an integral. Then this property, the summation property, and there are a few of them that are very similar to integration properties, except instead of d over dx you have integral from a to b. And some of them are a bit different, like when you're breaking down the two areas. So this property, you can see the picture. If you have function f of x, then in the rectangles that you make from a to b are of height f of x. If you have function in the pink, 2f of x, then the rectangles are of height twice that. And then that's how basically the integral of the function times 2 is going to be 2 times the function. I click at question 3. Suppose that integral from 1 to 5 of 2f of x dx is equal to 12, and integral from 4 to 5 of f of x dx is equal to 7, and evaluate integral from 1 to 4 of f of x dx. So the purpose of the question is to use the properties. You can stop the video and try to look up the properties. This one is a very interesting question, and I want you to try it a few times before looking at the solution. Okay, so how do I go about this? Look at the bounds. Bounds here 1 to 5, here 4 to 5, here 1 to 4. Apparently the bounds are not matching. But I see that I have 1 to 4, and then 1 to 4 is basically, I can write, remember it's a sum, right? If I sum from 1 to 5, then subtract basically the area from 1 to 5, then subtract the area from 4 to 5, what do I have left? It would be the area from 1 to 4. So remembering this is an area makes the remembering of the property easier. So this is what I'm ending up with. And here, here I have a 2. Here I don't have a 2. What do I do for here though? And so integral of 2 f of x dx is equal to 2 integral of f of x dx. Let's put the bounds in. 1 to 5 and 1 to 5, and that would be equal to 12. So integral from 1 to 5 of f of x dx is equal to 6. And over here I see that 1 to 5 is equal to 6, and over here it's equal to 7. So 6 minus 7 and negative 1 is the answer. Next I click here. I click here question 4, and let integral from 0 to 1 of y squared dy be 1/3. Evaluate integral from 0 to 1 of 8 minus 6y squared dy. Again, look up the properties and come up with the answer. Now that you look up the properties, and let's see, we know the integral of a sum of two functions is going to be integral of the first one and minus, it's actually difference of the function, so I write difference. 0 to 1 of 6 y squared. Sorry, this was dy. See my error. dy. And then over here, integral of constant is going to be constant times b minus a. Go look it up. And then over here, I know that integral, after I pull a coefficient out, I end up with this. Remember, we used to pull out the coefficient out of the derivative sign. And so you have 8 minus 6 times 1/3, which is 8 minus 2, or 6. So this is the answer. Okay, question 5. Suppose that f and g satisfy this property, satisfy this values, that integral from 0 to 2 of f of z dz equal to 3, integral from 0 to 5 of f of z dz equal to 2, integral from 0 to 2 of g of z dz equal to -4, and integral from 0 to 5 of g z dz equal to -1. Use this information to evaluate integral from 5 to 2 of f of z minus 2g of z dz. Okay, so remember that this format we've seen before with derivatives, except that here, on top of the fact that we're doing the difference of two functions, we also have bounds involved. And so maybe stop, compute, and then come back. Okay, I hope you have done the computation. See, the lower bound is 5, the upper bound is 2. Here 0 and 2, 0 and 2. Here 0 and 5. It seems like I can write this basically from 0 to 2 minus integral 0 to, let's write it as integral from 0 to 2 plus integral from 5 to 0, or 5 to 0, then 0 to 2. See, these two should be the same. And they are. And so these two are the same, so it becomes integral from 5 to 2. And then the function, which is f of x minus g of x dx, f of x minus rg z. Remember, this is just a variable, and this is another thing that I want to tell you. dz, and then over here, and the first integral breaks down into 0 to 2 f of z dz minus integral 0 to 2 f of z g of z dz, and then plus integral 5 to 0 of f of z dz minus integral 5 to 0 of g of z dz. Now, this first one is what? The first one, 0 to 2 of f of z dz, is 3. Then, oh, that one has a 2. So, 2 g of z. And then minus 0 to 1, 2 g of z dz. I'm sorry, 5 to 0. And so here 2 can come out, so you have minus 2. Then what you end up is with 0 to 1 g of z dz plus integral 5 to 0, and that's the negative integral 0 to 5 f of z dz, and this one also 2 comes out, and the other property is the sign changes, 0 to 5 g of z dz. So this is becoming 3 minus 2 times. This was 0 to 2, and 0 to 2 gz dz is right here. That's a -4. And then Over here you have another sign negative, 0 to 5 of f of z dz, which is 2. And then you have 2 times gz dz from 0 to 5, which is negative 1. So it's 3 plus 8 minus 2 minus 2. 8 minus 4 is 4, and 3 is 7. And that's the answer.